All right, greetings everyone. Welcome to the first part of the video for section 7.4. And in this video, we'll be doing something a little bit different than what we've been doing the rest of the chapter. But it's kind of some interesting stuff, and this is actually one of my most favorite topics to teach in this course. So let's take a look at this. So we're going to start with an example. So let's say we have a population of Pikachus, which live in the Viridian Forest. And for any of you Pokemon fans out there, hopefully this reference will make sense, and hopefully Pikachus do live in the Viridian Forest. Otherwise, I'm just way off my game here. But regardless, so this population lives in the Viridian Forest. It currently averages 1,500 Pikachus. And that average has been growing by 3% each year. So you might imagine that, out in the wild over the course of a year, the number of animals in a population will fluctuate as, older animals are die off, or if they're eaten by predators or something like that. So the average throughout the year will fluctuate, but what we have here is that we're told that from year to year, though, there's growth in that average. Okay, so it says that due to seasonal fluctuation, the population oscillates from 40 below the average in the winter up to 40 above average in the summer. We need to find a function that models the number of Pikachus after T years, where we assume we're starting in the winter. Okay. Now, as we've seen in the past, to write an equation for something like that, we have to use, or something like this, I should say, we have to use a formula of the form either f of t equals a times cosine of bt plus k, or f of t equals a times sine of bt plus k. Okay. However, in the situations we've looked at in the past, the value for k has been our average, right? In some of the previous situations we've looked at, for example, the ones with temperature, that number being added on the end there was the average value. But in this case, our average changes over time, right? It's not going to be a constant number in this case, because notice, as we were told up here, there were 1,500 Pikachus, but that amount is changing by a certain percentage every year. So what we're going to have, instead of just a number being added here on the end, is we're actually going to have a function being added because the average changes. And in this case, because we're told that the average is changing by a percentage, that means our midline will actually be filled in with an exponential function. So something like a times b to the t. Okay, so let's go about writing our equation now. And we're told here, first of all, that our account starts in the winter. And notice that we're told in the winter, the number of Pikachus is 40 below the average, meaning it's going to be 40 below the midline. And if we're starting off of the midline, well, we know that that tells us we're doing a cosine function, right? Because cosine functions start off the midline. So we're using a function of the form f of t equals a times cosine of bt plus, and then again, instead of k, we're going to have a times b to the t. And as we just pointed out, we're starting below the midline. We said that it's 40 below. So we actually know our value for a, that'll be 40. But because we're starting below the midline, that's going to be a negative 40 times cosine of, recall to find the value for b, we need to know our period, which it looks like we're told here that the average is going by an amount each year. So it looks like we're thinking about our period as being one value over a year. So to find the value for b, we can do 2 pi divided by the period, which in this case is 1 for 1 year. So the value for b would be 2 pi times t plus. Now, when we go to fill in the values for our midline, we have to recall what these things stand for. So recall the value for A here. That'll be the starting value. And then the value for B will be what we call our growth multiplier. Which is given by 1 plus R. And yeah, so we need to fill in those values here. So we're told the starting value, right, for the average or for the midline. That starts at 1,500. And then because it grows by 3% each year, that tells us that 3% is our value for R. So we can plug that into this 1 plus R. We have to convert it to a decimal. So the 3% is 0.03. So 1 plus 0.03 be 1.03. So we have 1,500 times 1.03 to the t. And there we go. That would be our equation then. So f of t equals -40 cosine of 2 pi t plus 1,500 times 1.03 to the tth power. And again, note that for the midline there, we have an equation, right? Rather than just a single value because it changes over time. All right, so next thing I want to do is actually look at what this function would look like if we graphed it, just so we can see what's going on. So we go to here, I believe, share that, and then hopefully right now we can all see calculator. Okay, so notice here I've already input the equations, the -40 cosine 2 pi x plus 1,500 times 1.03 to the x power. And if we graph that, then you see what we've got here. So notice, first of all, if you look really closely, you should see kind of some oscillations there. So it is oscillating up and down. But notice, instead of going up and down around a single value like we're used to, something like this, right? Because the midline is changing over time, then the function actually curves along the midline. So if I were to kind of draw the midline through the middle of this, and I know it's hard to see because of the scale we're working on, we get something like that. And hopefully you see that that is an exponential shape there. So kind of neat. Again, like I said, this is one of my favorite topics to teach because of this. All right, so let's go back to PowerPoint and take a look at what we'll be looking at. So as we saw, that last example was an example of a trigonometric function with a change in midline. So if we have a function of the form f of t equals a times sine of bt or a times cosine of bt plus g of t, where that function in place of the midline again now as a function, then we know that it oscillates above and below the average given by the function g of t. Okay, so we can see some different examples of what this might look like. So we could have a midline that's linear. And as you see in this first one here, notice again the midline there is a line slanting, in this case slanting upwards, and the function is oscillating above and below that. In the second place here, we see a times sine b to the t of a times b to the t. So there's our exponential again. And again, if you look at the midline there, it's an exponential form, and the function is oscillating above and below that. And then finally, and this one's a little less common. You won't see it in many of the problems we do, but a quadratic midline. So in this case now, that midline there, quadratic form, and the function is oscillating above and below that. So we see that would have a form f of t equals a times sine b to the t plus a times t squared, the quadratic form there. Okay. But as I mentioned, the ones that we'll be most concerned with in this class, and the ones that I'm most concerned with you knowing, are the exponential midline and the linear midline. All right, so let's take a look at one other problem related to this. So our favorite pop star, obviously Queen Beyonce, has opened a ski resort at Crystal Mountain called Best Bungalows by Bay. The resort currently averages approximately 2,500 visitors annually. And that average has been growing by 700 people per year. And throughout the year, the number of visitors oscillates by about 500 people above and below the average. And the greatest number of visitors is during the winter at the beginning of the year. And we need to find a formula for a function v of t that gives the number of visitors v to the resort after t years. And so we know this will be one of those forms from the previous slide. We have to think about which one. We also need to think about whether this is sine or cosine. So let's deal with that first, whether or not this is sine or cosine. Well, we're told in the problem here that the greatest number of visitors happens during the winter, and that's at the beginning of the year, meaning that the trig function is at its highest value, which would be off the midline at the beginning of the year. So that tells us because we're starting off the midline, we should have a cosine function. Okay. Plus, and then we need to figure out what type of a midline we're going to have here. Well, again, looking back at information given in the problem, we're told that there are 2,500 visitors annually, and that total has been growing by about 700 people per year. So notice in the previous example we looked at, there was a percentage given that we were growing by a year, but this time we're given an amount that we're growing by every year. And because it's an amount, that tells us this is going to be a linear midline. So that would be mt plus b. So anytime anything is growing by a certain amount or decreasing by a certain amount, that's a linear function. Okay, so now we go through, write our equation. So we get v of t equals, so a would be the amount, that's our amplitude, the amount we go above or below the midline, which would be 500 in this case. We're also told we start above the midline because we started the greatest number at the beginning of the year, so we can leave that as positive. Times cosine of, oh crap, I wrote 2 pi t, which is what it'll be. I should have put a capital B there, not 2 pi. But just as in the last one, we know that the value for b is given by 2 pi over the period, which again here looks to be 1 year, so we'd have 2 pi. Plus, now our slope, the value for m, that'll be the amount that the function changes by each year, that the midline changes by each year. In this case, that's 700 t plus the value for b, which would be our starting value for the midline, which in this case, we're told is 2,500. Okay, so there would be our function. V of t equals 500 times the cosine of 2 pi t plus 700 t plus 2,500. All right, and then we're asking the second part of the problem to use our answer to determine how many visitors will be visiting the resort after 5 years. So they give us a value for t, so we can just go ahead and plug that in. So do v of 5 equals 500 times cosine of 2 times pi times 5 plus 700. And this is something we need to make sure we pay attention to. We have to plug in for t here as well. So 700 times 5 plus 2,500. Can plug that all into the calculator, and I would suggest doing it all at once. When we do that, it looks like we get 6,500 visitors visiting the resort after 5 years. So business is going to be booming for Queen Bay by that time. All right. Okay, that's it for now. Thank you for watching.